Welcome back to Building Better Developers. And one of the things that we stress is the idea of strong fundamentals, that you build on a foundation that is solid. That is one of the things that we found as an issue with some boot camp type approaches or books that, learn X, whatever it happens to be, learn C# in 24 hours, some of those kinds of things. They have their place and they can be valuable depending on what your background is. But if you're going to become something other than a coder, if you're going to become a developer, you need to understand the theory and the reasoning behind why things are done the way they are done. You have to understand how software is built and why we build it in the way we do. And so that brings us to our focus in this lesson. We want to talk about SDLC, which is the software development lifecycle. Now, this is something that is very basic to software development. This is not some new fangled buzzword thing. SDLC has been around for decades. We're pushing a century of this being around in some way, form, or fashion. Now, granted, it wasn't really formalized until all of, it's pretty new, 50, 60 years ago, something like that. But it is a basis for a lot of what we do. And so I want to talk about, why do you need to know it? Why is it useful, even if you can write code, for you to have a good, solid understanding of SDLC and what it is? Now, I want to step back a little bit and talk about the definition of it, because sometimes it's one of those things that we just sort of like software development lifecycle might as well be blah, 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 blah. We don't really think about what it means. So SDLC is the best way you can, I think, picture it in the real world or in a physical creation of a product is an assembly line. If you think of an assembly line for an automobile, there will be, depending on how they do it, but at some point there's people putting together pieces for the tires. And there's somebody putting together, or teams of people putting together pieces for the chassis and the frame and the body, and then even the internal stuff like the seats and the steering wheel and the stereo, and all of those things are pieces that are built with people that are specialists in building that thing because they do it. Or these days, there may be a robot that knows how to build that thing, to put it together. And then you go along the assembly line and you start putting pieces on this thing. And when you get to the end, you have an automobile that you can drive away. That is what SDLC attempts to model. And so there are these steps along the way. And just to be clear and to reiterate that, there's 6 steps that are part of the SDLC. The first thing you do is you gather requirements. Then you design your solution, and then you implement it. And then you test what you built. You deploy it, you go put it in front of users, and then you maintain it. So you do bug fixes or updates, things like that. Each of these steps is critical to the entire process of SDLC. In this essential piece of it, these essential steps, there are definitely some things that we need to think about, that we need to understand, that we need to be comfortable with in order to be good software developers. So you may say, I can write code, I've built little applications, why do I need to know this? Well, one of the things is that each step is important. We can easily, and this gets pointed out over and over again, if you read any articles that are on, or surveys, research done on why is software often struggling to meet budget and expectations and be on time, and why does quality continue to be a problem? Why do software projects fail at rates that are not low? I think if software projects failed at like a 5% rate, people would be jumping and screaming and throwing parties in the street. There'd be parades and everything. It's not even close to that. It varies depending on who you're talking to, but it's typically more like 25% to 40%, depending on the projects and things like that. And when you look at the research on those, you often find that there were steps that were skipped. or that were not done properly. A common one is gathering requirements. People just put together a couple of things sometimes, a couple bullet points, say this is what we need to do. And then you get into design, and then that starts asking questions that point to gaps or holes or complete blind spots in the requirements. And then same thing, it's maybe design isn't done as well. And you get into, or both requirements and design aren't done very well, you get into implementation, and there are questions. There are things there where it says, hey, we can't build this because you haven't specified it, or you haven't told us how it's supposed to be done. You haven't designed it, or you didn't even, have a requirement that really addresses this piece. And it happens all the time. So these are software fundamentals. If you are building software, not writing code, if you're writing code, you can write code for, a window or whatever it is. You don't really care outside of your little function that you're building for your code, or your functions you're building for code. If you're building an application, if you're building software, if you're putting these things together, you're doing more than writing code. And these are fundamental pieces to doing it. You need to have requirements and design and implement. You need to test it, and then it's got to be deployed, and then maintain it. So what SDLC gives us, and a reason where it's useful for us to even if we are experienced developers, go back every so often and think about SDLC and how we are building software. Looking at that, or with a specific project even, it helps you sort of assess, did you forget something? Is there something, when you looked at the time and the resources spent on your project, is there something that's a gap, or something that looks like there wasn't much there? For example, let's say you get done with your software and you're looking at all the hours that were done on it, and there were, let's say, 10,000 hours done on implementation. Then you look at testing and there were 10 hours done on testing. That should jump out to you that maybe you didn't track your testing properly, or you didn't test properly. Now, it could be that you did a lot of testing and implementation, and so you weren't able to properly address those or account for those hours. But it may also be that you were just code. You were on a deadline, so it's just like basically just a rubber stamp, a few hours of testing, boom, you're off and running. That would be a gap. Or if you're looking at all that time, same project, that maybe you spent 5 hours on requirements. Maybe that's part of the reason it took you 10,000 hours of implementation, because you didn't spend more time in requirements. Maybe if you'd spent 50 hours in your requirements, you would be down to 5,000 hours of implementation. There's definitely a cost for finding something out, finding a bug or a hole, the further you get into the process. Now, another thing SDLC gives you is a way, like I said, it's like a non-specific way to build software. So if you've got an approach or a methodology that you're using, you can validate essentially your methodology, and you can even sort of test the value of your methodology by mapping it back to SDLC. If you have an approach, if you're using a methodology that doesn't design, that says, no, we're not going to worry about design, we're just going to go from requirements right into implementation, you're probably going to struggle. And by probably, I would bet a lot of money that you will struggle, that you will have issues. Because that means the design's got to be done somewhere. If not, then you're almost just like a step above randomly writing code. So you want to make sure that all of your steps in SDLC are addressed in whatever the methodology is that you use. Now, along those same lines, is you can use SDLC as a way to troubleshoot or improve your processes, because you can go look at those 6 steps, just as we've described here, some of the examples. You look at those steps and say, am I giving it the proper, we'll say, respect? Am I giving it the amount of time? Am I putting the right kind of resources on that step or to address that step with an SDLC. Now, I'm not going to get too far into it because we have classes, we talk about it. There are situations where some methodologies sort of combine some of those things. So maybe requirements and design are done more or less at the same time. Or like, for example, if you use rapid application development, it's really, in a sense, you have requirements, design, and implementation all sort of going on at the same time. So you don't see maybe the separate steps. However, if you step back and look at what is done, look at the activities that are done using that methodology, you can see where, here they are doing the work of requirements gathering. Here they are doing the work of design. Here they are doing the work of implementation. So while they don't have to be separate steps, the work related to this step does have to be there. And if you are struggling in building software, then maybe one of the things to do is step back and go back to the fundamentals. Are you following SDLC principles, or are you shortcutting something? These are the kinds of things that are useful for us to have to become better developers. Otherwise, as I've sort of mentioned, you're just writing code. There's a difference between generating code and building software. And you need this fundamental, you need this strong foundation to be able to build software better. You need to understand the big picture. Otherwise, you're just writing code. Thank you for your time.